morning, I make this as I sit in bed and you are on the way to school. And I just want to say good morning. And I hope you all have a really good day and that I will miss you. Because I love to talk about rivers and water, life's source, I wanted to show this image. There's so many things that you can look and see from this river flowing downhill. I have talked and we have learned about a few of these. But as we do our stream table investigation, we're basically simulating a natural river and trying our best to understand erosion and transportation of sediment and deposition of sediment. This here is a setup of a stream table, an illustration of a setup of a stream table. You notice that the bucket is sitting above the stream table. That's very important. All groups need to make sure the bucket is sitting above the stream table. It does not show the lower bucket, but what it does show is that the sand here is cut off. So the last portion of the stream table should not have any sand at all. In order for a river to flow, you have to have the table slope. So it's showing something under there that is 10 centimeters high. Now I just pulled this off the internet, so it doesn't necessarily have to be 10 centimeters high for you to have water flow downhill. I made this with the Google application, like the drawing tool. These are supposed to simulate the two buckets. Right here is a bucket or a stream table from above. Notice that the river has one meander, and this line is where this would be the top of the stream table, and this would be the bottom of the stream table, and this here would be an area where there's not sand, and this area would have sand in it. I just quickly made that yesterday. Your objective today, we will not be playing with stream tables today, but your objective today is to design an experiment to test a factor which affects the time it takes for the sediments to reach the end of the stream table. You are simply designing today. You are not doing anything else. What does that require? It requires your notebook, a pen or a pencil, and a guideline. I'm going to walk you through the guideline. Okay. Your two options for independent variable in this experiment are slope of table. It's either slope of table. You can change the slope of the table, or you can change the number of meanders in the river, and that's up to you and your group members, of course. Every student, every group is going to have the same dependent variable. I will repeat that. Every group will have the same dependent variable. And that is, in quotes down here, the time it takes in seconds for the sediments to reach the end of the stream table. You will time it. You will start the time when you start the water down the table, and then you will stop the time when the sediment, when the first amount of sediment reaches the end of the stream table. So let me back up here. I'll back out of this. Oh, come on. You will be given this paper by the sub today, and it's a rough outline of what you need to do in order to design your experiment, your stream table investigation. Let's just say that I'm going to go through most of them. If you get the first part of this page finish today, you are in good shape. Actually, the first side of this page, you are in good shape. So let me go back to the... Okay. So your variables are simple. It's either slope of table or number of meanders. That's what you're changing. The independent variable and the dependent variable is the same for everyone. Your title of your stream table investigation is basically in this format: the effect of the IV on the DV. So I've written a sample one here. The effect of slope of table or number of meanders in the river on the time it takes for the sediments to reach the end of the table. That title is simply taking the independent variable and dependent variable into account. Your levels and trials. Now, on your paper, these two boxes or these two columns are filled out. I don't want those completed as of now. Your IV levels are what things will you alter. For example, if you're changing slope of table, then in here you might want to write the slope is, you could do, if you're putting 2x4s underneath the table to increase the slope, you could do 1 2x4, 2 2x4s, 3 2x4s. In reality, a 2x4, as you place it under the table, is only about, it's not 2 inches, it's about 1.5 inches. So 1 2x4 means you raise the table 1.5 inches, but we can talk about that when you are actually doing your experiment. But this is how, this is being very specific in what you're changing. If you're changing number of meanders, then 1, 4, 6, or 2, 3, 4, it's up to you. You're going to design your experiment. The repeated trials, how many data sets will be collected? I want to have at least 2 trials per IV level. So you need to at least have 2 here, 2 here, and 2 here. Again, ignore these columns on your paper. Now the testable question: how does the IV, which is either red or blue here, affect the DV, which is the same for every group, every student? The time it takes in seconds for the sediments to reach the end of the stream. This is very simple. Just fill in the blanks with what you've already figured out. The hypothesis, we've practiced with hypothesis this year. Please provide the correct format. Specify the IV. Specify if it's increasing or decreasing. The word change is illegal here. You do not use the word change in a hypothesis. You specify the change. Same with the DV. Is the DV going to increase or decrease? And then the because section. You should provide scientific reasoning for your hypothesis here. Now, what I haven't mentioned is the background. With our notes and our assessment last week, you should have some sort of scientific reasoning for your hypothesis. You should have some sort of background knowledge on this. So you need to provide a good reasoning for your hypothesis. Looks like that is it. If you get this far with the hypothesis, then you are in good shape. Again, all writing should go in your notebook. And let's just leave this here. If you have any questions, I will be in class tomorrow for you. Thank you for listening.